All right, so now what we're going to do is we're going to go ahead and look at how to identify outliers. An outlier is a data value that differs significantly from the rest of the data set. An outlier can be an extreme value on the high end or an extreme value on the low end. And just because something looks like an extreme value does not necessarily mean it is an outlier. So there are a few different ways to identify outliers. We are going to focus on one method, which is using quartiles and the interquartile range. So the first thing we're going to calculate is the lower fence. This is the lower boundary for determining an outlier. Any value smaller than the lower fence is considered to be an outlier. The lower fence formula is the first quartile minus 1.5 times the IQR. And we want to make sure we remember our order of operations. So make sure that you do this multiplication first, then do the subtraction. And then the upper fence is the upper boundary for identifying outliers. Any value larger than the upper fence is considered to be an outlier. And that formula is Q3 plus 1.5 times the IQR. And again, we want to remember that order of operation, so the multiplication comes before the addition. So we're going to go ahead and determine if we have any outliers in this data set. Now this data set I did not pre-sort, so you want to take a moment and go ahead and figure out what the correct order of this data set is. I have done that, so I'm going to go ahead and start listing them out. You can fast forward through this part if you are able to do this faster than me. Or you can just keep following along. 76, 77. All right, and that should be everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data values. And I started with 14. Perfect. Okay, so again, we have 14 data values, and we know that if we have an even number of data values, we'll end up with 2 in the middle. So I'm going to go ahead and start crossing out one from each side. I'm still doing all of this by hand, even though we know we have ways of using technology to help us with this, just so that we make sure that we understand where all of this is coming from and we're still getting that good practice. Okay, so 77 and 78 are the two that I end up with in the middle. So to find the middle of 77 and 78, I add them up and divide by 2, and that's 77.5. So this is Q2. I have to find Q2 in order to find Q1 and Q3, which is what I need in order to find the lower fence and upper fence. So then the bottom half of my data is going to be all of these numbers. So I'm going to repeat this process with the bottom half. So cross one out there and there, cross one out at the bottom and the top, bottom and the top. And then I had 7 numbers on the bottom, so I should only have one number in the middle. So my first quartile is 75. And then for my third quartile, these numbers above 77.5, those are the ones that I'm going to use. So 78 and 84. Keep going until I get one number in the middle. And that is my Q3. All right, so that's the basis for setting this up. So now if I look at the equation for both the lower fence and the upper fence, they both rely on the IQR. So the first thing I need to come out and calculate is the IQR, which is the interquartile range, which is Q3 minus Q1. So my Q3 is 80, and my Q1 is 75. So my IQR is 5. So now I can calculate my lower fence. So my lower fence equation is Q1 minus 1.5 times the IQR. So Q1 is 75 minus 1.5 times 5. So do the multiplication first, 75 minus 7.5. That is 1.5 times 5. I'm just going to double check that. Yep, 7.5. And then 75 minus 7.5 gives us a lower fence of 67.5. So before I look at my data, I'm going to calculate the upper fence. And I'm going to do that with this color. That's the same color. Okay. Sorry, I'm getting caught up in my colors. Here we go. And then the upper fence. So that formula is Q3 plus 1.5 times the IQR. So Q3 we found is 80 plus 1.5 times 5. 1.5 times 5, that didn't change, so that's still 7.5. It should be the same because I'm doing the same multiplication. And then 7.5 plus 80, that is 87.5. And that is my upper fence. So now we need to answer the questions. Are there any data values less than 67.5? And are there any data values greater than 87.5? So our biggest number was 84. So no, there are no numbers bigger than 87.5. So we don't have any outliers on that side. But if I look at the other side of my data set, I have 49, and 49 is less than 67.5. So 49 is an outlier. And then I'd want to look at my next number, which is 71. 71 is bigger than 67.5, so 71 is not an outlier. You can have more than one outlier, so you don't want to just look at the biggest number or the smallest number. You want to keep going until you don't have an outlier. So it's not just good enough to look at the smallest number. You have to keep going until you find a number that's not an outlier. But in this case, there was only one, and that number was 49. So this is the calculation and also the identification of outliers.